All right, welcome back, everybody. Conceptual physics, projectile motion. Today we are talking about angled launches. What are angled launches? They are projectiles that are launched at an angle that have an initial velocity both in the x and y direction. So far, we've just been talking about zero launch angles, which are angles that are just don't have an angle. But today, what we're going to be doing is we're going to talk about angles that do have an angle. So, for example, it could look something like this, and it'll be launched both in the x and the y at the beginning, or it could be even angled downwards like this. Okay, so let's hop into it. Okay, a rock is thrown with a velocity of 32 meters per second and an angle of 30 degrees above the horizontal. What is the initial velocity of the rock in the x and y direction? So when it says it's thrown with a velocity of 32 meters per second and it's done at an angle, that means the angled part or the hypotenuse part is what that speed is, 32 meters per second. And this angle here is 30 degrees. So there's two components to this hypotenuse. There's the x and the y. Since this is the velocity here, it's thrown at 32, we can find what the velocity is in the x and the velocity here is in the y. Okay, so we should have learned with in vectors how we can do this. We're going to be using SOHCAHTOA, but just an easy trick whenever we have a horizontal angle like this, then we should be able to know to find the velocity in the x direction. The formula for that is the initial velocity times cosine of the angle. So in this case, what I can do is to find this Vx, the initial velocity is 32 and the angle is 30 degrees. Now I can use this to plug this into my calculator, 32 times cosine of 30, and I get 27.71 meters per second. Okay, so I found the velocity in the x, 27.71. So if you want to kind of copy this formula down or whatever, that's how you can find it. And remember, this is, or you could use SOHCAHTOA, you'd get the same answer. And this is whenever the angle is on this horizontal plane like this. Okay. And for the y direction, the formula for that, or the equation, is Vy is equal to initial velocity times sine of theta. So initial velocity in this case, again, is this 32. And then sine, again, the angle is going to be 30. I don't have to put in my calculator. I know sine of 30 is 0.5, but you can if you like. And this is 16 meters per second. Okay. And that's the answer right there. So we can use SOHCAHTOA. So for example, I'll use cosine for this one. So ka is CAH. So cosine in this example of 30 is equal to adjacent, which is this here, which is equal to velocity in the x, divided by hypotenuse over here, which is 32. So what we would do is we put 32 on the other side, and we do 32 times cosine of 30 is equal to Vx. And we can see that's the same thing that we did over here. Okay. Okay. Anyway, you can use SOHCAHTOA, or you can just kind of memorize this here to solve for these kind of problems. Up to you. Okay, moving on. A rock is thrown with a velocity of 28 meters per second and an angle 50 degrees above the horizontal. What is the initial velocity of the rock in the x and y direction? Okay, since I did the last one, I would highly suggest you pause this and try to do this one on your own, but I'm going to start working on it. Okay, hypotenuse is 28 meters per second. This angle here is 50 degrees. And we're looking for this velocity in the y and the velocity in the x. So again, I should know velocity in the x is going to be equal to this hypotenuse, 28, times cosine of 50. So let's put that into my calculator. That's 18 meters per second. 18 meters per second. And I should know velocity in the y is going to be equal again to the hypotenuse, 28, times sine of 50. Okay, so I put that in my calculator. 21.45 meters per second. Okay, and that's our answer there. Okay, again, you could have done SOHCAHTOA and you could have found the same thing. Probably would have taken longer, but anyway, there you go. Okay, now conceptual question. An object is shot from the ground and follows a parabolic path as shown in the diagram below. Point B is the highest point on the path. At what point is the ball going the fastest? Okay, so an object is launched. This is the launch right here. Boom. This is the initial velocity, and we have point A, point B, point C, and point D. And we're trying to find at what point is it going the fastest. Okay, so a few things we could do here, but we should know that at this lowest point here, it's going to be going the fastest. And it's actually going to be going the same speed as right here, but there's no point there, so that's why we're picking point D, okay? The direction is different, but it's going to have the same speed. Okay, let's look at this example here. Similar but different. An object is shot from the ground and follows a parabolic path as shown in the diagram below. Point B is the highest point on the path. At what point is the object going the slowest? Okay, so again, we have these 4 points A, B, and C, and D. I think most people are going to know that B is going the slowest. One thing I want to say is a lot of times people think at point B, the velocity is equal to 0, and that's not correct. The velocity in the y direction is 0 at point B, but the velocity in the x direction is not 0, okay? But it is going the slowest at point B because the velocity in the y direction is 0. Okay, moving on. A golf ball is hit with a velocity of 28 meters per second at an angle of 30 degrees. What is the speed of the ball at the very top of the projectile's path? Okay, so a few things we should know here. When this golf ball is hit, it's going to have a velocity in the x direction and a velocity in the y direction. Okay. Another thing that we should know is as this golf ball is traveling, the velocity in the x direction is always going to be the same. We're going to figure out what that is. But the velocity in the y direction as it's going up is getting smaller and becomes 0 at the top. And then as it goes down, it gets faster and faster. Okay, so just like a refresher with that. So at the very top, we should know that the velocity is all in the x direction and there's no velocity in the y direction. The velocity in the y is equal to 0. But what we should also know is this velocity in the x that it was initially hit with is going to be the same throughout because the velocity in the x is constant. Okay, so let's figure that out. We should know that this angle here is 30 degrees, and we should be able to find what Vx is knowing that. So I'm going to kind of draw this out again. We have this at 28, 30 degrees, and this is Vx. And I should know Vx is equal to the hypotenuse 28 times cosine of 30. Let me put that in my calculator. 28 times cosine of 30. And we get 24.25. Okay. So I hope that makes sense. Let's look at this next example. Unable to leave the cubs helpless, Rolina decides to make pumpkin soup for the cubs. In the middle of the night, some wolves come looking for food. To get rid of the wolves, Rolina throws a pumpkin 1 meter from the ground at an angle of 30 degrees with a velocity of 15 meters per second. The pumpkin takes 1.2 seconds to hit the ground. Calculate the speed of the pumpkin at the maximum height. B, the speed of when the pumpkin hits the ground. So you guys should be able to do part A on your own. I would highly suggest pausing it and try and do that. But I'm going to do a few things here. I'm going to draw out this problem a little bit easier, and then let's do a few things. So Rolina here is throwing this out at 15 meters per second. She is throwing it at an angle of 30 degrees. And I'm going to kind of draw these components here. And she's also throwing it 1 meter off the ground. We should also know when this pumpkin is flying through the air. It's going to take a time of 1.2 seconds. Ooh, that's hard to see. Let me put that somewhere else. Of 1.62 seconds to hit the ground. 0.62 seconds. Great. Okay, I think that's everything that we have here. So let's put everything we know. Let's first make our chart, our x and y components. Again, I love starting with acceleration because that's almost always the same. Acceleration y, -10 because of gravity. Acceleration x is 0 because it's constant. Okay. Next thing, anything else we know? I guess we know that the time in the air is going to be the same for both. 1.62, 1.62. One thing we do not know is we have the velocity here, but we don't know what the velocity is in the x direction and the initial velocity is in the y direction. So maybe we could figure that out first. So this Vx and V initial y, let's figure that out. Maybe I'll start using a different color. Use green. Okay. Again, I can find Vx. This is going to be equal to the hypotenuse, 15 times cosine of 30. So this will give me 15 times cosine of 30, 12.99 meters per second. And I'll put that right here, 12.99. And the initial velocity in the y, which is going to be 15, the hypotenuse, times sine of 30. And I know sine of 30 is 0.5, so I should know that this is going to be 7.5 meters per second. Okay, great. Okay, let me use another color again. Next thing I should know, the first question is, what is the speed of the pumpkin at the maximum height? So this highest point, let's say it's around there, we want to know what the speed is. And again, what we should know is at the highest point, the velocity in the y direction is equal to 0. But we should know that the velocity in the x direction all throughout this motion is constant. So if it started with a speed of 12.99, that means also at this very top here, it's going to be 12.99 meters per second, okay, in the x. So what A is just going to be 12.99 meters per second. Great. But now we want to know what is the speed of the pumpkin when it hits the ground down here. So you may be thinking, oh, well, it was thrown at 15 meters per second. That means shouldn't it be the same at the beginning and the end? And that's a good thought. However, the problem is the reason that's not the case is because it's not thrown from the ground. It's thrown 1 meter off the ground. And because it's not level, that means that it won't be going 15 meters per second over here. Okay. It would actually be going 15 meters per second on this opposite side, like around here, looking at the diagram, but I don't want to confuse you. Okay, so let's figure out how fast it's going over here. A few things, let me use a different color, to know is that in the x direction, we're going to know that it's going to go 12.99 meters per second. But in the y direction, we don't know how fast it's going. Or B. Okay, so final velocity in the x is equal to 12.99 meters per second. But we should know the final. We need to figure out the final velocity in the y. So let's using what we know here. Let's figure that out. Okay, so we have these four. Let's look at what formula is going to help us in our formula sheet. Okay, that was from way back. And we know it's this manipulated formula. Final velocity in the y is equal to initial velocity in the y plus acceleration in the y times time. So this is going to be equal to 7.5 plus -10 times time, 1.62. And let's see what we get. 7.5 plus, we get -8.7 meters per second. Great. So now that we have the final velocity in the x and the y, It's asking for what the speed is when the pumpkin hits the ground. So a lot of times people will just put 8.7, but that's not correct. When it's asking for the speed, it's not asking for the speed in the x or the speed in the y. We have to combine it. So it's going to look something like this. It's going to be going 12.99 in the x direction. It's going to be going 8.7 in the y direction. So the speed is going to be this one here. Plus 8.7 squared. So that's just the Pythagorean theorem there. A squared plus b squared equals c squared. But let me just do this. And we get 15.63 meters per second. Okay. Boom. And that's pretty much it. All right, let's see what happens here. Oops. The wolves devour the pumpkins and become satisfied with the offering. Okay. As the cubs start to get older, Rolina has to find ways to entertain them. The cubs love to chase rocks, so Rolina kicks a rock, sending it over a high tree. The rock lands at the same level from which it was struck after traveling a horizontal distance of 17.8 meters. If the rock left the ground 54.6 degrees above the horizontal and landed 2.24 seconds later, what was the initial speed of the rock in the x direction? Okay, so again, let's kind of draw this out. Let's draw all the things that we know. I should underline some things. Okay, horizontal distance of 17.8 meters, left the ground 54.6 degrees, landed 2.24 seconds later. Okay, so Rolina's here kicking this rock. We don't know how fast, but we do know it is at an angle of 54.6 degrees. Let me erase that. 54.6 degrees. We also know that she kicks it a horizontal distance of 17.8 meters. Great. And we know that when it finally lands, it's 2.24 seconds. Great. First question here, and I'm going to change colors. Let me not do that one. Let me do red. Okay, we are going to be looking for what is the initial speed in the x direction and the y direction. Okay, so what we're trying to find is this here. V initial y, Vx. Okay, so shouldn't be too hard. Part A, we should know at this point Vx is equal to the initial velocity. Oh, actually, we don't know what the initial velocity is. Oh, so that's what makes it hard. Okay, let me start over. Okay, so let's find everything we know in the x and y direction to help us here. Again, love starting with acceleration because it's always the same. Not always, almost always. And then let's see, what else do we know? We know the time and time is the only one that's the same for both, 2.24 seconds. And then we know the angle, but that's not really helping us here. We know the distance it travels, and that's horizontally, so that's in the x. 17.8. Okay, that looks a little weird, so let me just write that again. Okay, great. And what you should notice is we have 3 pieces of information in the x direction. Since we have 3 pieces of information in the x direction, what we could do is we could find that to find the fourth. In this case, we could find what Vx is. Okay, so part A. We should know we're going to use the only formula in the x direction since there's no acceleration, which is the velocity in the x is equal to displacement in the x divided by time. And then we're going to manipulate oh no, we don't even have to manipulate it this time. Great. Displacement is 17.8 divided by time, which is 2.24. And let's see what we get. 7.95 meters per second. Okay, 7.95 meters per second. Great. And let me just erase some of this here. Let me erase this because we already know that. So this over here is going to be 7.95. So I'm going to change the color. What we should know is we can find the initial velocity in the y. How can we find that? There's a few ways we can find that, but I'm going to use this triangle here to help me find that. So I'm going to use tangent. So if you guys remember TOA, so TOA, I'm going to use tangent of theta is equal to opposite divided by adjacent. Okay, and let's just figure out what this is. So we have tangent, which is 54.6, and hopefully you could look at your formula sheet for all of this, is equal to opposite, which in this case is going to be opposite to the side, is the initial velocity in the y, divided by adjacent, which is 7.95. So we should know that the initial velocity in the y is equal to 7.95, I'm just bringing this over to the other side, times tan of 54.6. And let's see where we get. Times tan of 54.6. We get 11.19 meters per second. Great. Yep, great. So part C now says, what was the initial speed of the rock? So we got part A, part B. Part C, let me change the color here. So this should be like relatively simple, since now, let's see, we have this over here. We have the X, which is 7.95. We have the Y, which is 11.19. And we have the angle here. So we can use this angle to find what this speed is. Remember, the speed is the combined value. Or we could use Pythagorean theorem, and that's what I'm going to do. Speed is equal to the square root of 7.95 squared plus 11.19 squared. Okay, so we're just using the Pythagorean theorem there. Plus 11.19 squared. Oops, sorry, I put into my calculator wrong. Sure, 7.95 squared plus 11.19 squared. You know, like when you make like one mistake, you like keep making mistakes. You guys ever notice that? So it's like whenever I'm taking a test and then I notice I made a mistake, I always look back at the previous problem and see if I made a mistake, because usually I've made multiple mistakes. Okay, anyway, sorry, tangent. What was the initial speed of the rock? 13.73 meters per second. Okay, if Rolina was to kick the rock with the same angle but a higher speed, how would this affect the rock's time of flight? Okay, so same angle, but we're now saying that she kicks it harder. We should know what's going to happen with the time of flight is just going to be in the air longer. And the reason for that is because the initial velocity in the y would be bigger, so it'd just be in the air for a longer time. Okay. All right. One of the cubs starts to eat the rock and gets a tummy ache. That is not good. All right. Let's look at this next problem. Bill and Ted stand the same distance from Farmer Bob's barn. They have identical potato guns which fire potatoes at identical speeds. Bill holds his potato gun horizontally, but Ted aims his upward at an angle of 10 degrees above the horizontal. If they fire simultaneously, which potato will hit the barn first? A, Bill's, B, Ted's, C, they will hit at the same time. Okay, so let's say, I'm just going to do an example here. Let's say that they're both their potato gun fires at, let's just say 100, I don't know, meters per second, miles per hour, whatever it is. Let's just say 100. Okay. Well, maybe pause it and think about it. And if you're ready, we should know that when Bill shoots his, what we're gonna it's gonna fire, and then it is probably gonna go down a little bit like that. And we know Ted's, when his fire is gonna kind of go up and then maybe level out, something like that. Okay. But we should know that the answer is going to be bills. The reason why it's bills is it's gonna the one that's gonna hit the barn first is the bullet or the potato gun or the potato that's going to be traveling the fastest in the x direction. So whichever velocity is the most in the x direction. Since Bill is firing his completely horizontal, that means that it's going to be getting fired in the x direction with 100. But for Ted here, since his is at an angle, I don't know exactly. I guess it's a 10-degree angle. Let me just do the math. 100 times cosine of 10. This is going to be fired at around 98. And what that means is the velocity in the x is just less than in Bill's. So it's not going to be getting here as fast because in the x direction, it's not traveling as fast. I hope that makes sense. All right, guys, we're going to leave it here. We have still a lot more problems with angled, but I'm going to leave that for next time. So I hope to see you with that. Thanks for watching, everyone. Bye.